Hello, geometry. We're back. Chapter 5 is going to be all about parallel lines. Okay, so we're going to start with just kind of an intro that's very generic for 5.1. There will be 2 assignments associated with this video. So, if you could do this on a separate piece of paper so it's not as messy. All right, so the first thing I want to talk about are these 3 terms. 2 lines that can be parallel, skew, or perpendicular. Now I think we've talked enough about this first and last one, but this one, skew, might be a little bit difficult to ascertain. So, what are parallel lines? Here's the formal definition for parallel lines as we see them in geometry. Parallel lines have 2 qualifications. 1, they do not intersect. I think everybody's aware of that one. But 2, they must be coplanar. They must be on the same plane. And I'm going to use the word coplanar. We talked about that last chapter. It just means that they would have to be... Oh, what was that? Sorry about that. That was a Zoom meeting. So they're coplanar. So when they ask questions about, 2 lines that may be parallel, so line AD would be parallel to line BC, because they never intersect and they're on the same plane. Just like line AE would be parallel to line BF. Line CG would be parallel to BF as well. So, those are the formal definition for parallel lines. We have not really incorporated this part of the definition into parallel lines, so you're going to have to burn that into your memory right here. So, parallel, check. Skew. Skew lines are basically the same thing as parallel, except there's the one difference here for the number 2. They also do not intersect. But the difference between those is that they're not on the same plane. They're not coplanar. Not coplanar? Non-coplanar? So an example of 2 skew lines would be AE would be skew to BC. They're not on the same plane, nor do they intersect. AD is non-coplanar to EF. Okay, so parallel lines, skew lines. What are perpendicular lines? This should be review. 2 lines are perpendicular if they intersect at right angles. Perpendicular lines intersect, and they must intersect at right angles. So we've got these 3 definitions for these 3 types of lines that can interact with one another. So we're filling in the blank if they're either parallel, skew, or perpendicular. So let's check out AB versus DC. So here's AB, here's DC. Those lines are coplanar, but they don't intersect. They are coplanar and they don't intersect, those would be parallel. So number 1 would be parallel. How about AB and BC? So here's AB, here's BC. We know that there's a 90-degree angle over here. We're just going to assume that that keeps playing out in every part there as well. So they end up being perpendicular lines. So number 1 is parallel. Number 2, those lines are perpendicular because they meet at 90-degree angles. How about BF and FG? Here's BF, here's FG. Those also intersect at 90-degree angles, so they're perpendicular. Okay, AB and FG. Well, here's AB, here's FG. They exist on 2 separate planes, and they do not intersect. So that's the definition of skew lines. Now, I want to throw one thing out here so that you guys don't get confused later on. There is technically a plane that can connect diagonally that we're not seeing right here, okay? So let's say we took the line segment AE and we connected it diagonally with CG. All right, can you guys see that? There's technically a plane that can pass from AE to CG. So if somebody asked you, how would you compare AE and CG? I think your first tendency would be to say that they're skew lines because they don't look like they're on the same plane, but you have to visualize that opposite diagonals can connect to create planes. So AE and CG would technically be parallel line segments. By the way, here's the symbol we use for parallel. You just do a double slash. They look like little parallel lines. So then EF, you could have one that connects down to DC. All right? EF to DC can create another separate plane. Okay, moving on. So we know what perpendicular, parallel, and skew mean now. This one's a little more freeform. They're just asking you to give one example of each of these. So name a line parallel to MN. So parallel to MN just needs to be on this plane right here, which doesn't intersect with it. So MN would be parallel to LP. And how would we write that? We would write it with a line segment and a little arrowhead above it. There we go. There's one line that would be parallel to MN. It's not the only one, though. You could also envision MN connecting down to QR. If MN connects down to QR, then you technically have line QR is parallel to MN as well. It just says name one, so you don't need to, but I just want to be absolutely clear that LP and QR would both be parallel to MN. Who's perpendicular to PR? Well, PR forms a right angle with LP. So LP would also be an answer for this one. But it's not the only one. PN is also perpendicular to PR. Because it creates a 90-degree angle down here as well. How about a line that's skew to SN? So it doesn't intersect SN, and it's not on the same plane. LP doesn't. Looks like LP is the answer for almost all of them, right? How about LM? Would LM ever intersect SN? No. SN just goes up forever like this. LM's just going to go forever in that direction on a different plane. So LM works. Do you see any other ones? Now, one might think that QL would work, but remember, a diagonal plane could connect QL with SN, meaning that they are technically on the same plane and not skew. All right, and then lastly, planes that are parallel, that's also a thing, so they just don't intersect. RPL is this plane right here. What would be a good name? What would be a name for a plane that does not intersect RPL? Well, it's not this plane because it shares RP. It's not this plane because it shares PL. It's not this hidden plane MLQ because it shares LQ. It's the plane that's created by M and S and some unknown point down there. So it's going to be plane. You could just use the word plane. M and S would be parallel to LPR. All right, so this is the answer for 5, 6, 7, and then there's 8. And again, I hope you guys are doing this on a separate piece of paper so that you can use this as a clear, clean visual, and it's not just a cluttered space that you can't really rely on when you're doing your homework. All right, last one. Hold on, I gotta scroll down on the other computer. Complete the statement with, we got to do some defining here. You know what? I'm going to do this in a second video so you guys can get kind of a mental break from this. And we're kind of switching gears with a different concept anyway, so seems like a good stopping point. Thanks for watching.